So in our previous video, we defined vector-valued functions, which are just functions that have input a real number and output a vector in R3. Our last example was this example, the vector-valued function that sends t to cosine t, sine t, t. The input is a real number and the output is a vector that I've depicted below with the red vector. So the red vector is what I get from plugging in a certain value of t into this vector-valued function. And as the value of t changes, I'm going to get different vectors which point to values on this blue curve. So here's an animation of what that could look like. As t changes, I'm getting different red vectors which trace out the blue curve. This particular shape is known as a helix. It's a spring shape. You could see that a spring is created because in the x and the y coordinates, I'm getting a circle, the parametric equations for a circle, while the z coordinate is stretched out. Let me alter this function, see what happens. So instead of doing t, let's do t divided by 10. So there's my new vector valued function. I'm going to change the starting and the ending points. B is 10 pi. So here is my new function and my new value. This gives me a more compressed spring because as the circle rotates, the z-coordinate doesn't travel as high. It travels 1/10 the height of the previous example. So I still get a helix, this time more compressed. And I can see the different values of t give me different vectors that trace out the curve. So let's do a few new examples. I have a different vector valued function here I'd like to try. So let's put that up here. Here's my new vector valued function I'm going to test out. I have the vector valued function that sends a value t to 1 plus cosine 2 pi t, sine 2 pi t, and 2 sine 2 pi t. Let's put that in and plot our vector valued function. So this is the new curve. It's like maybe an infinity sign with a twist in it in R3. So I get a vector valued function which traces out the values on this curve. So here's the animation. As I plug in different values for t, I get different vectors which give me different points on the blue curve. Vector valued functions are the key tool in understanding motion in space. So if you have something moving around in space, a particle or even a spaceship going from Earth to Mars, you might use vector valued functions to describe its path of motion. Okay, see us on our next videos for more on vector valued functions.